Okay. There we go. I've got the recording rolling.
All right.
And now let's share the screen and let's get going. So, this was this is going to be the training template. It's not the same as your DIY setup template. This is specifically for training.
Okay.
I have basically some case studies or specific examples that I've laid out, and we'll just kind of march through it because I do think that it's useful information to have. And I know that you've definitely done a fair bit of programming.
Correct.
Yourself.
I have the UR5, the old ones. I think it's 9 or 10 years old.
Yeah.
It has CB, so I get how it all works.
Yep.
The UI looks a little different on this one. It looks a lot easier.
Yeah. And so I'll do my best to try to speed through the things that feel like, okay, if you generally have been programming universal robots for a while, you wouldn't necessarily need to know, all of this stuff. I'll do my best to gloss over that. And then there's certain things that are specific to our system that we would say, hey, this is a good idea, or we found that this works really good. I'll try to point those out, but even still, like given that you have the experience that you do, we can go through that more quickly so we can get to your programming template specifically.
And then I've got you gave me a program that was called ThornTech or whatever it was. I saved that again as another copy. So when I make changes, I just keep saving new versions of that. Okay.
Yep. Beautiful. Yep.
Okay. Just wanted to make sure. I didn't know if it was gonna save the sub programs all to one place and overwrite stuff. I wasn't sure.
Nope. So if all you have here, so if you have your sub programs listed, you can keep this box checked or unchecked. Keep sub program file updated with this program. So basically, it will just then generate a separate sub program within your file structure on your pendant, and then you would be able to refer to that sub program from any of the other programs as long as the box is checked.
Say I have a program called, cup holder, and I have a program called fishing reel.
Yeah.
The program for the cup holder, the subprogram Vice One Open, is totally separate from Vice One Open in a different program, right? Or
correct.
Okay, correct. It's not global.
They are isolated. Okay. Correct. Okay. They are local, not global, and you can make them global by hitting this checkbox.
So basically, never hit that unless it's really important.
Yes. Yeah. Yes. The only reason you would do that is if you were like, hey, I just want to have one repository for all of my subprograms, and then you just want to update a subprogram and it applies it to every single robot program on your template on your pendant. That's the only reason you do that, and I don't think like
no, because I'll be moving jaws and fixtures and I haven't run into that yet on any of our programs in 5 years. So
to be honest, neither have I. And I've been doing this. I've done I don't know how many robot installations. We haven't ever felt the need to do this to check this box, but I would say that there is a use case for it. We just never run across it because of our application. Just hasn't gone there. So, we'll just kind of jump into it then. You had a question on Friday about the routing the airlines. I'm assuming you got that sorted away. And did you end up seeing the videos that I'd posted just lightly describing, hey, things to keep in mind when putting those airlines on the arm?
I did. I put them on. I mean, I've run the airlines on my other robot plenty of times. I was just kind of seeing if you had any tips and tricks. You guys gave me a few tips and tricks, and I left plenty of slack, so I can make adjustments if need be.
Perfect. Yeah.
You have all the poses kind of pre-programmed in there, so I was trying to run through the home position that you set up, and then the other ones just to make sure it was bending the right way. I run into issues where with my other setup where I grab a part and I bring it over the top, and so I run into like singularity issues. I run into cable issues with the gripper that I have on that robot. So I just wanted to make sure. But the airlines are they're way stronger than that cable I have on the other one. So it's
yeah, totally. So I guess we don't even necessarily need to get into the that because basically this little demo here describes exactly what you're talking about, where you get kind of a wind up, or like your cable kind of gets snagged up and tangled and wants to like pull itself out of the end effector, depending on how you have it. Because like for me, I've found that like, see, if you look at the wrist 1, wrist 2, positive 202 minus 302 versus negative 157 and 57, like basically you do like a 360-degree like reset in either direction to unwind the cabling. And that's something that I always tell customers is like, hey, when you're going through your program, make sure you don't accidentally wind up one way, so that when you're going to your next waypoint, you don't have to unwind 360 to get that extra 3 degrees, because you might have run out of,
Yeah, I that happened to me last week programming the other one, and it was honestly the first time that it happened to me, I think, ever, where it just going over the top for some reason I can't not go into a singularity situation, and in doing so, it was also overwinding and it pulled everything tight. So, but your setup's got a lot. It's a lot better than the eBay special I got over there in the corner. So
okay, yeah. So I guess with that, I'll just very briefly gloss over this. One thing that we've found that we really have come to appreciate a lot is there's a lot of times where you have tracking variables in your program, using assignment node. We always just, sometimes the robot needs that to be initialized to a specific value before it can be used. And it doesn't always tell you right away. So we always just have an initialize variables folder in the before start. And then I just categorize it by, gripper, infeed, CNC, just to kind of keep it. And that just kind of helps keep things straight in my head. And whenever there's something that happens.
I've got in my other programs, I've got that before start, set your variables to what you need them to be.
Yeah. Yep. Exactly. And then for general operators, we always just have a pop-up that says, hey, before you hit and go, make sure that the CNC and the robot are in the correct state. Like, hey, do you have the right program pulled up on the CNC? The robot manager program, etc.
I usually add in the actual program number to that, so that an operator knows, hey, make sure this is the program. They can look at the host control and see that it's the right program number. Okay.
Yeah, and furthermore, if you have have you had a robot that has the ability to send a macros to the CNC?
No, I am completely independent. It operates it as if it's a human, and I can turn the robot off and just keep
Where you're literally
running
just hitting the cycle start. Yep. Okay.
Yeah, it's doing it through a relay, but yeah,
exactly.
I wired it into the foot pedal, so on the lathe, it opens and closes the collet. On the mill, it opens and closes the pneumatic tool holding using the foot pedal. But you can still use the foot pedal, or the robot will use the foot pedal.
That's awesome.
So it's literally like it's a robotic machine tender.
Yeah, that's awesome. We've definitely been able to capitalize on that when someone has a foot pedal and they use it all the time. We'll be like, oh yeah, we can just wire into the foot pedal, so you have parallel control with the robot and the human.
Yeah, it's been clutch for us with the we have a 4th axis with a tailstock in our VF2.
Oh, yeah.
So what we do is we take a lot of second op lathe parts, slide them in the 4th axis, and then we just barely open the gripper, and we close the tailstock, and we have a valve on there, so the tailstock closes faster than the collet. So the collet doesn't fully close, so the tailstock pushes in, then the collet closes and kind of centers everything. Then we retract the tailstock, which happens faster. The collet opens a little bit, and then we reseat it, and then we check for the part with the gripper, and then we leave. And so that's all done with a foot pedal. But that's I think that I won't be set up like this in this machine with this robot.
Yeah. Okay. Let's see. Oh yeah, no, we're not going to go into that one. Nesting, maybe waypoints. Not even going to touch that. Movement. You know about move J, move L, and when to use which. That's something you learn through time.
Okay.
This direction. Do you use direction much?
I've never used direction.
Okay, direction is super, super cool. So there's different conditions that you can apply to it. There's expression, distance, tool contact, and IO input. Like say you have a waypoint where you're like you've picked the part from the Optuvise, and
Okay.
you're like, I don't care where the robot is in space. Like, I just want it to move vertically in machine Z to get out of the vice jazz. You don't have to teach an explicit waypoint. Like, you could do a waypoint and then say, okay, jog the robot up in Z, and then teach it.
Okay.
Or you can just say,
I do moves like that, but I don't think they're called direction in the older robot. Where
oh,
it's like
okay, interesting.
where like it'll be like from wherever you are, move 5 inches this way or whatever.
Okay, yep, that's what it
Yep.
is. It's the same thing. But this one has until distance, until contact, where you can specify.
Yeah, that's really nice. Okay.
Like, and you can also the thing that they've added in since 523, I believe, has this force threshold. You can change how sensitive it is, which is absolutely mind-blowingly useful when you're trying to find a part with a vacuum cup.
Okay.
So
Yeah.
for our in-feed setup, we have the robot going down to find a part with the vacuum cups. And so you'll have a stack of parts that says, I don't care how many parts are in the stack, I'm just going to go down until I touch something. And if I touch on the same place twice in a row, then it'll say, okay, I hit something real. And then it'll say, okay, now I can try to grab a part. And we'll get into that more.
So you can tie that into your pallet and not worry about crashing as much.
Yeah, 100%. It's super useful.
If someone adds material,
yeah,
and
yeah,
you didn't catch it, you're not rapiding into a stack of material.
absolutely. Okay. Yep. So, and we'll dig that into that specifically in the palletizer once we get to the main program. But just know, until contact, that's one of them. It's really useful. I always use high deceleration just as a general note. 3,000 millimeters per second squared is typically good enough for what we need it to do. And I don't know if you've used this. Well, you said you haven't. They recommend less than 100 millimeters a second for tool speed when you are doing this. So this direction here has to be spec'd to less 100 or less. But we have found that 40 millimeters a second is a really good number. And then also, so if you were to have like if you were to think of like have you ever seen the robot kind of, if you have it decelerate really sharply, have you ever seen it kind of like oscillate back and forth just very briefly? Like it's really quick, but you can kind of see it with the eye where it kind of like shudders a little bit upon stop. That same concept applies to if the robot has an acceleration to start moving very quickly. So you might get an oscillation as it's harder to track because the robot is already in motion, but you can see the robot. If you were to go in a slow motion camera, you'd see the robot doing this number where it's oscillating as it takes off. So one thing that we've noticed is that if you have a much slower acceleration for this specifically, direction until contact, this is very sensitive. At 5 newtons, it's going to detect things that are like very, very minute motions in the robot arm. So what we've done is made sure to specify the acceleration to be slow and smooth enough that it doesn't introduce artificial oscillations that would cause
your speed to be 40 and your acceleration to be 125. That's what you recommend?
Yeah, typically.
Screenshot that, yeah.
Okay. But yeah, just that allows, because if you have a heavy end effector with you're carrying a heavy part and you go out of the hole really fast, basically that heavy, think of it as like a heavy weight at the end of a stick. And so it's like that weight can cause actually magnify the oscillations that you'd see with a sharp acceleration, and then that would actually register as a tool contact with the force torque sensor, like the tool at the tool flange.
That makes sense.
So that's the main thing. So and then playing around with your force threshold may be useful. I typically when I'm doing tool contact, keep it at 5.
Like 5?
Okay. Yeah, and then if you have a specific need for direction until force, this one we've used for like when you are trying to push a part into a collet that's fairly tight fitting. like to give the robot some compliance and some ability to like just, hey, I just want you to jam this thing until it hits the backstop in the lathe. And then so you'd have a direction, you'd choose your feature, CNC plane, whatever the direction is, until expression force greater than 20. So you have to manually type this in, like it would be greater than 20, force greater than 20. That basically will say if the force torque sensor senses anything in any direction, any force in any direction, then it'll say once it exceeds 20 newtons, boom, it'll stop. There's different use cases for that, but more or less just know that if this doesn't necessarily work this direction until contact, you can also use expression force, and there's a little bit more compliance in some ways, a little bit less in other ways, but it's also a valuable tool. Also, again,
that's an either or kind of situation.
Yeah. Yep. And then another thing is with direction, you can have multiple untils stacked up. You can just keep adding untils, and it will basically monitor all of those simultaneously, all of those stop conditions. And the first one that it runs across that is satisfied, then it'll say, okay, here we go. We're good to go. And so it won't
it
wait
doesn't
for
do
all of
in
them.
order.
It'll wait for
it's
one.
Okay.
Correct.
Okay.
So it'll say until either it goes 5 millimeters or it hits something.
Gotcha.
And then you can also, in addition to that, click on this add action button, and that will allow you to say, okay, if you've gone 5 millimeters, then do this. If you run into if you run into something, then do a different thing. So that's also very useful. It's like a built-in if statement. Very handy to have.
So you can probably set that if you're, say, loading a part into a vice jaw and it hits a force before a certain coordinate.
Yeah. Yep.
Say retract, move a little bit in one axis, try it again.
Yep.
Okay.
Exactly. We've done exactly that. It's been a little bit less compactified than this, because this was actually a recent addition. This add action button was maybe like 5.19, 5.20. So we had a lot of infrastructure built up that didn't use this. But either way, that's what you would use it for.
I mean, my other machine is so old that there is not a timer built into the control.
Oh, wow. Yeah, that's wild.
You have to program a timer in every program if you want to use a timer, like a wait.
Yeah.
Yeah.
So I guess if you are feeling it, you could probably just try. I recommend playing with this a little bit. You don't have to play with it right now. I'll also send you this template so you can open it up. But yeah, if you just do a direction base Z minus until tool contact, you can feel how sensitive it is.
Okay.
And yeah, if you would like to do that, like to try it right now, you totally can. Otherwise, we can.
I think I'm fine. I'll goof around with that. I've got this. I'll have this video to look back at. And I don't need to take your time to play with that.
Okay. So the other really useful one that you capitalize on a lot is force. This is largely used for when we are pushing something to basically clamp it. We push while clamping the same way that person does when you're loading stock into the a vise.
Okay.
Or into the chuck, and you say, okay, make sure it's snug and square, and then clamp. The robot, you can do the same thing. You can do it the simple way and just apply it in one direction, or you can do so. Normally, it's a simple mode. Let's see, templates, force. Normally, it's just in simple mode. That's the default, but we always use frame because it allows us to specify the axis and the direction. You just check it. And then you type in negative would be, so for the X direction, -5 newtons is just in the negative direction.
And that's Z is in the base. If you were loading a machine, would you set that to base or machine?
I'd do a CNC plane. Did you happen to use your tool probe or your Renaissance probe tip to set up your CNC coordinates, your CNC plane with respect to what the robot sees?
I wondered why there was a Renaissance probe in there. I did not.
Yeah. So I don't know if I've got some easy accessible photos, but more or less, I guess I can just describe it briefly. If you have a bolt head in your machine, all you need to do is find a bolt head where the Renaissance probe tip, and it should be screwed into a like a steel post, like a 1/2-inch diameter post that's like maybe 6 inches long. The one that you got should have that. or there should be a post included in there, because that actually clamps. If you look at the gripper jaws, those slider rails has a round feature on the inside of it, so like you can clamp onto that post.
Okay.
And then
yeah,
you can use that.
You sent there was this extra post from the in feed.
Yeah, the extra post, you thread the Renishaw Pro tip into
the
it.
chopstick grippers, and then I've got this Renishaw probe. Okay, so that's a.
Yeah, so you'd use that to basically set up. Have you ever used the TCP wizard?
No.
Okay, so another useful thing for that, like we're getting a little sidetracked, but that's totally fine since we're here. Not sidetracked, we're getting ahead of ourselves for some very useful information. What I typically like to do for programming practice is like I set up a CNC plane where if I set up my plane correctly, then I can tell the robot like, hey, this is my my CNC plane, and I can move exactly in the direction that the CNC table is set up, so that like if I want to square up to my vice jaws, then all I do is go to my move tab and then go, oh, I want to go with respect to CNC plane, and then I want to edit my tool position. I want it to be square, so we're just going to route it the nearest 90, including minus sign. And then you tell the robot, okay, now move to that position. And now the robot is perfectly square. Like that TCP is dead square with respect to the CNC coordinate system.
Gotcha.
And then that makes it really easy to snap to that coordinate system, and then you just use the jog tab.
Because all your moves are going to be 90 degree. Yeah.
Yeah. And then it really allows you to snap to, and it just makes life so much easier when you're picking up points, because then you know you're square to your coordinate system. So given that, your TCP, if you were to say, so if you click on your TCP probe, then hit measure, it tells you to bring your TCP center point, which in this case is the Renishaw probe tip when it's clamped in the vice in the gripper fingers. You set 4 different unique points in space where the Ruby tip is in the same spot. It's just oriented differently. So you just use a bolt head on like the infeed, their infeed breadboard. There's just a bolt head, and then you just put it to 4 different positions, and then you say, okay, set all those points, and then it'll automatically read those points and say, okay, your TCP must be here.
Okay.
And then once you've done that, then you can go into the machine, and if you find a single bolt head,
and it knows that probe is whatever that is, 6 mil diameter.
Well, it doesn't need to, because if you put the Ruby probe tip on a bolt head that's smaller than 5 millimeters, because that's how big it is. If it's 5 millimeters or smaller, then if you as long as you jam it into the top of the bolt head, like say it's a button head Allen, and it takes
you want it in the actual hex.
Yeah.
So in the
yep.
Oh, okay.
Yep.
So put it in the hex. Okay.
Yep. In or on the hex. Because if it's a 4 millimeter hex, you have to put it kind of like snug it up to it. But if it's a 5 millimeter hex, you dump it all the way inside, and then it's nice and tight.
Okay, so that perk fits perfect with what you have.
Yes,
I got you.
That's on purpose.
Okay.
We grabbed a 5 millimeter on purpose for that reason specifically. So then you can do the same thing with a bolt head in the machine. If you set your machine, like your load position for the robot, where you say, okay, this is the table position that I want the CNC to have the table go to when the robot is supposed to load the part. If you start with that position and you find a single bolt head that the robot can reach, and you save that as like when you're teaching your feature, like say I grab a plane and then I go teach this plane, it's going to ask me these 3 waypoints, 1, 2, 3, to say my origin is my point 1, the X direction is the point 2. We
should be able to find some. So I could put like a bolt head in anywhere, right?
Yeah, anywhere. And then the genius thing about that is that once you have that one bolt head, then you just move the table in machine X and then hit the same exact bolt head.
Oh, that's slick.
And then
Okay.
you move in Y because it's after you've taken your second point, the robot says, okay, now move in the Y direction from this point. So you want to go up
Okay.
here. And so you just do the same thing with the machine table. You move it in Y and then register your third point. And that way, it like then the robot knows exactly what the machine coordinates system like orientation is, and it works great for being able to like move locally in that coordinate system. So highly recommend getting familiar with that with the probe, and then additionally, this is something that it depends on the application, and it depends on if you're switching out your fixturing to go from job to job. Say you have job A that uses a Kurt vise, job B uses an air vise, and then maybe you have two vices versus three vices. It's a 2-op versus 3-op, whatever it might be. Then those vice positions might move ever so slightly. You're not going to be able to necessarily dial it in so tight that your physical location is the same every time.
Right.
If you use your move tabs, do you ever use the feature under your move? So you click a move J and then you teach it with respect to a feature.
Uh, as far as like choosing when I do a move.
Like when you teach a waypoint, are you linking it to a feature that is not the base
Yeah.
coordinate system?
So generally I'm linked to the base, and then I have,
Yeah.
because my other robot, I have riv nuts on the face of the machines, and I
Yep.
have so the table rolls to the machine, it bolts to the machine, and it's set up in a way that it's level and
Oh, yep.
aligned, so I don't have to
Yep.
reconfigure that.
Yeah.
So
Right.
my
But
my base and the machine are all kind of collinear.
okay. Yeah. So given that, this isn't necessarily like a mandatory in my books, but it definitely is very helpful if you know that you're going to be shifting your fixturing in the table, like the physical location of the fixturing on the table, like it'll
Okay.
switch from time to time. You can basically teach all of your waypoints in a subprogram. So you have like unload op one, and there's waypoints associated with unloading op one in the
Okay.
op one vice. You can attach it to your CNC plane, or you can even attach it to a specific vice plane. Like if you were
Gotcha.
to generate a vice one op one vice plane, op two vice plane, then that way, if you as long as you have a bolt head on each of your fixtures that you can repeatedly pick up that position, then it will basically just automatically snap all of your waypoints that were taught with respect to that feature. It'll just snap in, and you don't have to re-pick those points up ever, even if the fixturing moves. All you have to do is pick up
So if I
reteach
so
this.
basically just if I just drill and tap a 6 mm hole
Yeah.
somewhere on the vise, I can put a permanent M6 in there and just leave that
Yeah.
for a. Okay.
Yep. And that's it's up to you. It depends on if you find yourself reteaching waypoints and you feel like, man, it would be nice to just go over to the installation tab and reteach the
I
vice
I mean
one
I
plane.
do on my other setup, but we have this one set up with a fixture plate, so I'm hoping that it's not
Oh
the
yeah,
case.
then you shouldn't
You know.
have to worry if it's a fixture plate. Yeah. But just know that that's out there, and it's actually really useful. There's been times where
Okay.
we've saved a lot of work by just snapping to the CNC plane coordinate system. But yeah, just figured that's worthwhile to know that it's there, so that in the future, if you're just like, oh man, it'd be nice to not have to reteach all of these things, there is a way to do that. Um, Expression generator. Have you used this a lot, where you're just we use if statements and then clicking on this field to generate some.
Oh yeah,
Um,
a
yeah,
ton of stuff. Yeah.
yeah, that's super powerful.
Yep.
I won't get into it then because you already know, like, because you can do compound statements, right? You
Yep.
can do and or and a bunch of those, and you can. I've told customers you could literally say, do this if it's Saturday. If the robot's running and it's like, oh, check if it's Saturday. If it's Saturday, do this other thing. Like you could literally generate an expression that tells the robot when it's Saturday. And so, like, you can do any number of things um, with it, and it's super useful. But you already know that, so we won't go into it. If you don't know about this, subprograms, have you ever tried to call a subprogram from within a subprogram?
So I've used subprograms, but I want you to walk me through it because again, the CB subprograms, it's just kind of a listed program at the bottom
Yeah.
of the screen. So you just go to the bottom and there's your subprogram. It's not stored somewhere else, as far as I know. Like it's just there.
Yeah. Yeah,
Um,
no, that's the same for this series. The E series is the same. Like this, these are all my subprograms.
is that what that is? Okay.
Yep. And so if I were to want to edit it, whatever, I would go down and edit it. And it doesn't necessarily like the subprograms aren't being called in this order, right? It's just whatever you call
Yeah, I
in the main
noticed that. Yeah.
program.
Yep.
Like you click normally when you call a subprogram, you call it using this button in the advanced tab, and then you just select whatever, with the drop down, you'd say, okay, I want to call C part. That's how you do it in the main program.
And can you start, because I don't have this functionality, can you start partway through? Like if I pick a point, like, hey, I want to try running just a subprogram, can you just test that out? Or do you have to start all the way back at the beginning of the whole program?
For our template that we've given you, there are things in the before start that have to be suppressed.
Okay.
If you want to be able to run just the sub and just run just that little chunk of it. So I actually find myself when developing a program for a customer, I'll suppress a lot of the stuff in here that I don't need active because it'll say, okay, go to this waypoint before you start. And I'm like, no, I want to stay in the machine. So I would.
Yeah, sometimes that's not. It's not. I don't, like I said, I don't have it. I have to restart a program every time.
Yeah.
But it's nice for, especially like loading material into a vise or into a collet, just to make sure that everything goes in at the right speed and location.
Right, rather than having to have the robot walk through the entire program.
Yeah, that's the most time-consuming part about setting it up is, going through the whole initialization, pulling a finished part out, going to your infeed, picking up a piece of material, and then bringing it in just to see if your coordinates work.
Yeah, so what you can do is just suppress if there's something that you can. Yeah, you're exactly right. You can just go to the subprogram, expand it out, and then click here and then hit play from selection. So if I were to go, play from selection. So it would just play that subprogram.
So if that doesn't work, it's because of the before start stuff.
Yes, correct. It's just because there's stuff in there.
So just suppress the initialized variables.
No, you shouldn't have to suppress initialized variables. That's like assignment nodes, just like assigning variables. Okay. That shouldn't matter. But like cell initialization, there might be in yours, there might be a move J, home point. Might be a home point there where it says, okay, drive the robot to the home point before hitting go, like this right here. Gotcha. You might have a move J home point. So suppressing that and then hitting go, that would take care of it. Okay. And then, another thing you will find in our template that we have subprograms dedicated to like controlling the gripper and controlling vices. And traditionally, the Universal Robots Polyscope does not let you call a subprogram from within a subprogram. So if I have in my grip part subprogram, if I try to go advanced subprogram, it says, no, you can't do that because of a thing called recursion, which maybe you're familiar with. It's just the programming phenomenon of self-referring. Like if I called grip part from within grip part, then it would just basically endlessly go deeper and deeper into the self-referential loop of spiral of death. It's a recursion error. So that's the reason that they don't let you, but just know that we call subprograms from within subprograms many times using a script call, and you just type the name of the subprogram, and then open close parentheses. That allows you to call a sub from within a sub, and it's very nice because there's a lot of times where I want to grip apart, ungrip apart, open gripper, close gripper. I don't want to have to retype out all of this every single time.
Right.
I just want to refer to it once. I like that condenses the whole closed gripper subprogram. It just condenses it into one line of code in the main program, and anywhere else that it's needed, and it just makes it a lot more condensed and like it's just neater.
And so you're just doing that from within a subprogram, which right now those are subprograms. But I finish a part load program, then I go to gripper close subprogram, then I go to a retract per machine subprogram.
Yeah.
Kind of thing.
So yeah, it would allow you to clean up your code in that way without having to.
No, your program's phenomenally clean. It's like I can't even look at my old stuff now. This is phenomenal.
I've had a lot of time to like figure out how to make it more efficient and cleaner, and like it's always been something it's bugged me when I have code that seems like it's excessively bulky. So when I found out that you can call a sub from one of the sub, it was like a hallelujah moment. I was just so stoked. I was like, this changes everything. So
I just have a quick question for you because your naming convention is something that your team put together. If I were ever to add in a waypoint, if I had to add in a waypoint, is there on the newer Polyscope, will it tell me if a waypoint's already been used?
Yes.
Yeah. Okay.
What will happen is let's see if I can just show you here. If I generate another waypoint, if I try to name it endpoint bad, variable name already exists.
Okay.
But if you want to use the same waypoint, you're like, no, I actually want to use
copy
that.
And paste, yeah.
You can either copy and paste.
Okay.
And then that references it. And mind you, if you haven't, I don't know if CB series does this or not, but if you change the name of one waypoint, it changes the name in all of the waypoints because they're directly linked.
No, it doesn't, because if you change the name, then they're no longer linked.
Okay, yeah. So this one,
I copy and paste all the time, and then just change the names to sequentially like 7, 8, 9, whatever it is.
Oh, so on Polyscope 5, it does not if you rename, it does not automatically unlink. It automatically renames all of the existing waypoints that are linked that have the same name.
That is very good to know. Okay.
You would have had such a headache.
Yeah.
because
I'll have a spot where I like it, but because of some kind of reach issue or hoses or whatever, I'll have to add 3 points to get from point A to point B. It's now point A, B, C, D, E. So I'll just copy and paste point A 3 times.
Yeah.
Move, reset it, move, edit pose, move, and done.
Yeah. And that's what I do too. But there's an additional
step. Add new waypoints, yeah.
Yeah, well, you can either add new waypoints if you want to copy and paste it, because it's nice to be able to copy and paste to keep it local, where it's like that waypoint has the approximate location that you want. But if you want to do that, you'd go copy, paste, and then you'd make sure that you unlink it first and then rename.
Perfect.
There's the unlink button. So if you want to link it, then you would say, okay, I actually want to use endpoint.
So if it's linked, it has that drop down. So if you see that drop down, it's linked to that waypoint. Okay.
Yes, correct. Yep. So see how it's got the drop down, and then this link sign fills in blue.
So if I had a waypoint that's like like outside machine, where it's always the same thing. Outside machine, whether you're going in or coming out or waiting or whatever it is, you could add a waypoint without having to go find that one to copy.
Correct.
Hit the link, and then drop down to find that. Okay.
Exactly. So you have nice. Yeah, because our home point is designed to be like the return. It's like the hub on a spoke. It's like the home point always kind of returns you to your neutral position, and then anywhere else that you go. Yeah, this home point. Yep. Okay. And so that's how
that's the vacuum gripper down.
Yep. There's occasionally there's times where there's a specific customer that it seems more relevant to have it pointing upwards, but mostly we have it turned downwards. Okay. I don't even remember the rationale for it, but on occasion it's like, oh, it's nice to have it pointed up. But yeah. So say you wanted to use this home point elsewhere in your subprogram in a different subprogram, so you're going drop off part, whatever, you'd have your move, and then you'd say, okay, let me link it.
And then
Home
just grab
point,
it.
boom.
All right.
So then you don't have to scroll up and
Sweet.
find it, which is definitely more
That
useful.
is so much easier.
Yeah,
So
definitely.
much easier, yeah.
Let's see here. So yeah, back to the general walkthrough here. Great question, by the way. Subprograms, yeah, calling a subprogram something within a sub. We have this in our program, and just be mindful to take care that you don't create something called like a recursive loop, because and it's not necessarily that common. Normally, what I like to do with these subs is I'm either I'm making a sub that is like really low level, like just a tiny little function that doesn't do anything but like, so the seek part, it just goes, the robot will go down until it runs into something, then it'll retract and then go down again and check to see if contact point A and contact point B are close enough together to be deemed as like, oh, okay, I definitely ran into something real, to filter out false contacts in midair. So like this function does only that. And I'm not intending to call a subprogram from within this at all. Nor am I trying to call a subprogram from any of these other low-level subprograms of just a simple close device, grip the part, open the gripper, open the door, that sort of thing. And then that allows me to, within my main, I'll call them like my real subprograms, which is like load op1, unload op1, drop part off on cart, things like that. Then I can call these little low-level subprograms for within the real subprograms, and that just makes things a lot easier. So
the more complex programming stuff.
Yeah.
Not just moves. Okay.
Correct. Yep. So that's the last thing about subprograms. And then threads. Have you used threads before?
Yes.
Okay. Yeah. Just like for if you need to be a little bit faster, like if you're using two robo wrenches, with you can put each robo wrench on its own separate command thread, and then basically set the thread to execute. So you can build your subprogram of vice one open, vice one close, all of that, like just as a general, actual normal subprogram, and then you can, within a thread, you can call that subprogram given a set of conditions. So basically, this thread one will always be monitoring. It'll be looping and saying, okay, I'm checking for command vice one close and command vice one open, and I'm looking for those two variables. To make sure that, I want to, if any one of those changes state, then it's going to say, okay, vice one close, vice one open, etc. And then basically that's like sending a command to a separate thread to say, okay, now you can open the vice, now you can close the vice. That allows the robot to move about in space while that is being executed. Otherwise, if you just call it as just a subprogram without putting it in a thread and calling it that way, then when the robot calls vice one open, it might take 5 seconds for the vice to open all the way if it's opening, a half inch. And you're like, man, it's just sitting there. I want it to like call the vice to open earlier in the program, and the robot will be moving about space, and it's just more efficient. I can save 5 seconds on my door-to-door time. Then you'd put it in a thread, and then that would allow you to run the vice one open code in parallel to the robot actually moving about space. So just know that exists and that's out there. And if you do have questions on it, on how to run it, how to execute it, feel free to text, call, whatever, and I can give you just a couple quick pointers on it.
All right, I'll probably skip that for now, just because.
Yeah.
I don't run at hyper speed. For me it's slow and steady, but
exactly.
I'd rather go slow and nonstop than super fast.
100%.
Break something.
Yep. Yeah, and this is just something like if you're really chasing that cycle time, not necessarily like trying to run the robot at top speed, but just like eliminating unnecessary pauses.
Yeah, the job that's, we broke the boring bar, but the job that's supposed to be running on that lathe behind me, it's a 50-second cycle time. So shaving 5 seconds off is a big deal.
Totally. So
10%. Yeah.
Yeah. So if you can shave time off, like sometimes using threads does let you do it. It takes a little bit of time to think through, but like if you're like, man, if you crunch the numbers and you're like, if I shave off 5 seconds, that means I get this many more parts in a day. And you're like, holy smokes, that means that's on average, that's $500 or $1,000 a day. And you're like, okay, well, yeah, if I spend 2 hours, that's absolutely worth it because then I'm money ahead in no time flat.
Right.
So, yeah,
right.
That's available to you. And absolutely call me up if you have any questions regarding this or anything else in the training that we've done so far. So,
all right, appreciate that.
We will go into your template. And we'll kind of walk through that. So I'm just going to kind of like mostly just go through a couple points. I would say largely the get stock with reloading stock. Do you have that infeed set up yet? Like, is it able to pick parts from the infeed?
Yeah. Hold on one sec. Hey, Craig. Craig, can you do me a favor? Will you go grab me like a stack of like 20 of these plates for the hitch covers? Yeah. Grab a stack so I can work on. Thank you very much. Yeah, I've got it set up. I forgot to get the material when I was in here Saturday setting up.
Okay, gotcha.
So he's just gonna grab a stack.
Okay.
But yeah, I've got two pieces. One is in the op1 jaws. One is in the infeed, and I've set up I think 4 or 6 of the it looks like 4 of the infeed, like the little L pieces here.
Mm-hmm.
So I think this is one here. This is one. That looks like 3. I set up 3. Looks like. So, and then I set this one up here as a regrip if I needed it. So this is a job
sure.
This is a job I have to run next. It's not a very big job, so I just wanted to, for the sake of learning, just have a couple positions and not have a whole table set up.
Yeah.
Just a three position pallet, I guess it is right now.
Is it in a row, vertical row, or is it 4 corners of a square?
It's in a row, left to right.
Okay, gotcha. Sweet. Let's see here. So I guess just a little pro tip. Have you used the palletizer much?
Yeah.
Okay, because you know about editing the number of rows and columns, and it'll just automatically interpolate.
Yeah, this one looks a lot more in depth than what I'm used to.
Okay. Yeah. It may be worthwhile to go through because it is definitely useful to have, and I would recommend setting it up the way that it is here.
4 corners. Okay.
Yep. If you do the 4 corners, the sweet thing about this is that if you set up your 4 corners, then if you want to have 4, just 4 corners and nothing in between, then you just go 2 by 2. And you just set it and then hit OK. And then that just gives you the 2 by 2. But then if you want to add into the middle, if you want to add more, if you want to go 3 by 3, 4 by 4, 5 by 5, then all you do is you change the rows and columns. And as long as those 4 corners don't change position, it automatically just fills it in.
I gotcha. Yep.
So if you just set it up once, then you never have to set it up again. So I definitely would recommend setting it up that way.
Okay.
And then
will it reach the bottom? I noticed it came with these not all the way down. Is that just for shipping, or can I put them all the way at the bottom of the breadboard?
I would say that you would only be able to grab larger parts if you put it all the way to the bottom.
Okay, so I'll just leave it.
How many holes below the bracket?
3 clear holes.
3 clear holes.
Yeah.
I might have to do a little bit of digging to see what.
I'll figure it out. I'll be able to look. I'll be able to figure it out real quick. I'm not too concerned because I'll just have a couple, maybe 2-3 jobs running on this. Then once I learn how I want the inflow, the infeed configured, and where I want the robot, I'm gonna move everything and get it all squared up.
Okay.
So this is sort of a preliminary setup just to learn it because it is so different than my other setup.
Yeah.
I mean, I have one of your angled in feeds for that one that you guys built
Yeah.
for that table.
Yeah.
But
Oh
I've
yeah,
got your
that's right.
robo wrench. I've got your robo wrench on it, but it's a much smaller in feed and it's higher than the base. So
Yeah. Yep.
I have to aim it at the robot. It's not reaching over.
Yep.
So
Yep.
it's very
I
limited.
remember us building that. Yep.
Yeah.
Okay. I guess with that, one thing that I will say that can save a lot of headache is before you set your corners
Uh-huh.
and before you put your brackets in their final location, what I like to do is I'll do a reach study for the infeed specifically. Normally, when we do a turnkey, we'll have the brackets already set up in position, and I can give you like a
Right.
snapshot of like the most common configuration for those brackets for us,
Uh-huh.
and changing it the long edge to be pointing left versus right. There is a more common usage. I believe it's with the bracket pointing to the left.
Oh, so these
Um,
are, I guess I didn't look at the bottom. They're reversible.
yes, yes, they
Oh,
are.
that's
They
cool.
have a counter bore
Okay.
on both sides.
Okay.
Yep.
Nice.
Um, but you may find that in some scenarios, switching it to the right is maybe a necessity.
Okay.
Also, pro tip, or maybe tidbit that you didn't know about is if you set up those brackets spaced just so, we have it set to be a 5x5 is that sweet spot. If you space them out just so, you can actually set it such that you can turn apart the other way without having to change the bracket the other way, because the end of the bracket
I
perfectly
saw
lines
that.
up
Yeah,
with the short L.
it's perfectly lined up. Yeah, I
Yeah,
saw
that's
that.
on purpose. So you can
Okay.
actually put parts the other way if you need to.
Okay.
Um, but that said, if you do a reach study, there's something that I have recently discovered that is super useful to have is if you're, say you're in your infeed plane. If I go to my infeed plane, let's see. I'm actually going to go. I always like to select my TCP, make sure that I'm using the vacuum TCP is selected when I'm going to do my reach study. Because then what I can do is uh, rotate this wrist around. Give me a moment here. So if you set one or two of the very bottom brackets in the infeed, the ones that are furthest away from the robot, that at
Uh-huh.
that point you would want to do a reach study, and then also the very top brackets that are closest to the base of the robot arm.
Right.
Um, so if I go like this, and I tell the robot, I want you to go to 000 with the vacuum cup. There we go. The robot will go down to that point and be squared up. But you may not want to pick those parts from that angle. So if I zoom in here, my TCP is currently locked to that orientation, but I might actually want to be picking at an angle. So I'm going to use the RZ TCP orientation, RZ plus, to rotate. If you pay attention to that elbow, it's getting really close to flat. Your max allowed is about, let's see, elbow. If you go below 20 degrees, then that's like max limit.
Yeah.
So if you're getting like this is really close. Like if I'm getting to this point and I still need to rotate further to pick it up, then I'm like, all right, I need to move my bracket, because if you go up in Z, you'll notice that the
Oh
elbow
yeah.
straightens out because you need to go away from the
I am
breadboard, right?
familiar. Yeah.
Yeah, exactly. So doing a reach study, what I like to do is get my robot in the correct orientation, like the exact, orientation, rotation. Say I want it to
Right.
be 45 degrees. If I know that the bracket's 45, then I'll just say, okay, I'm going 45. And then what I'll do is I'll just go free drive and lock all my axes, and maybe even if I'm at the right Z height, I'll even disable Z for my free drive. Click and hold the free drive button, and then that allows me to just basically grab the robot and move it around. in the infeed, and I can do a really quick reach study to make sure that there's no singularity points where the robot is not happy.
Huh.
And as long as you
So
do kind of just
do
a
that.
barrel
It'll
sweep,
actually let you. It'll let you change the free drive based on your
yeah,
feature. Okay.
yeah, it'll, yep, exactly. So if sorry, that's the other
I knew
thing.
you could
So
control. I knew you could do a move based on and lock out certain axes based on a feature, but I didn't know you could free drive
yeah,
it like that.
yeah, it's super useful. So yeah, you'd
Okay.
select your infeed plane, and then make sure that X and Y are the only things, or maybe
Yeah.
even Z as well, because it loosens it up a little bit, and you can still get a good feel for what's going on. Then you can just kind of move the robot around in space, and then get a good idea of where it should be able to reach and where it's like going to really struggle. So
Right.
what we found is that bottom left or the bottom right, furthest away from the robot, is typically your pain point. And then there's also the second from the far left in the top row, the one that's really close to the robot base. That is all your other primary concern is going to be right in that vicinity. So you just want to make sure that your robot isn't so close, like the top bracket isn't so close to the top of the breadboard that the robot runs into itself when it's trying to grab from that position.
Okay.
So keeping those two things in mind will potentially avoid a lot of headache, especially because then if you're reteaching all of this stuff in here, it can be quite the task.
And then
I
do
guess
you normally come over the top? So if you're on the infeed and I guess it's like a left shoulder. So you go to your infeed. Would you have the robot come over the top and then flip back into the machine, or do you try and have it like rotate around,
no,
or what do you
no, no.
normally do?
We actually keep we have it right shoulder all the time. We just always have right shoulder, and then what we would do is go to see if I have it available here. Get stock. My above infeed point is right here.
Okay, so you keep it as right shoulder.
Yeah, we always keep it as right shoulder, and then we just basically retract the elbow to about here, and then pivot at the base.
Okay.
So what you have
that's where I run into singularity issues with mine is doing like what I name it like over the top, like the over the top move, where I'm like in the lathe, and then I'm coming out, but because it's so close to the machine, I can't fully go right shoulder, so I go over the top, and then that's where it finds. Not normally, but lately it's been doing it where it doesn't like certain moves, and I'll add waypoints on the way, but it still just doesn't like them.
Yeah. So what we've done is if you move the robot, if you keep the robot far enough away so that this shoulder when in the right shoulder configuration, as long as the shoulder doesn't touch the door and you have some clearance on the door handle, etc.
I may have to move mine because, like I said, I didn't glue it down yet. I just basically set it where it looked about right, so we could get kind of playing with it.
Yeah, totally. And then that way you also avoid if you can keep the orient, and that's the reason why we do this is like if you keep the robot orientation right shoulder and then also keep your wrist nominally 180 degrees from this base position, then you never get wind up on your airlines or anything, because you're not doing any crazy flips. Although arguably at the base joint you actually get better results by doing an arm flip. You don't have to worry as much about your hose reach there. We just make sure to coil it up around the base such that if you have it maximally counterclockwise in the infeed, like it's going to the infeed, then then it has enough space, and then it unwinds as you go towards the outfeed cart. So, yeah. Let's see. Oh, for the infeed, and this is totally up to you. If you want to program things the way that you've always done it with the palletizer and the infeed, you totally can. I will say that the way that we have it set up allows you to just reload on the fly, and you never have to worry about resetting the robot when you add more parts into the infeed, which is great for end of the day activity or even middle of the day.
Okay, I clear. I clear the door handle on the rotation. I think the reason that it's an issue with the lathe is because the door slides on the outside, and so
Oh yeah,
the handle gets in the way sometimes.
yeah,
Um,
totally.
but um, the no, I want to use whatever you guys recommend.
Okay.
I like the
Yep.
idea of being. I have programs that run depending on how the pallet's set up. I have
Yep.
programs where I can add material anytime, and I have
Yeah.
some that are like specific. Like we have specific instructions out. Like if you add material, add it in this order because of how it goes
Oh
through, like on
sure.
a some kind of small part on like crazy 3D printed fixture jigs for
Okay.
grabbing parts and stuff. So
Yeah.
with this, whatever you guys know is robust and works well, I'm just gonna stick with that.
Okay. Yeah. So what I would advise is if you when you're going to teach your infeed, so you set up your corner items, and then you would go through the wizard
Yep.
for that at each item, and then it would just tell you, okay, what do you want to do for what your approach waypoints are. You once you teach that sequence, then you would want to add in a bunch of these additional lines of code into your, because normally all you see is just this. Uh, you just see a move L and then a waypoint, move L, waypoint, move L, waypoint, and then there's a tool action. We add a
Right.
bunch of stuff in this tool action, and essentially what it
Oh,
does is,
a
I'll
lot of
just
stuff. Yeah.
summarize. It goes downward. Uh, oh, here we are. It goes downward until it runs into something, or until it reaches the actual target point.
Okay.
And importantly, the target point is with the cups barely touching the bottom of the breadboard, such that you couldn't fit a part underneath it. If it reaches that waypoint, it knows that there's nothing in the stack. If it runs into something before it hits that point, it knows that there's something that was in the way of it on the way down, and that therefore means that there's a part there.
And you're not going across next row down across. You're doing one stack to the bottom, next stack to the
No,
bottom.
nope, nope, not
No.
doing. We're not doing that. We're going to we're marching through, but it just
Okay.
basically at each cell position, it goes down and finds a part, as opposed to just literally just moving blindly to that part and assuming that it's
Okay.
there.
So you're a square. You're not a cube.
Correct. It's a
Okay.
grid. We use a
It's a
grid, and all we do is
okay. Yeah.
we don't use a layer. We don't have a separator or anything. We just have a grid pattern, and we set the four corner items, and then we also set our object height to 0.01. So essentially, it doesn't matter how tall your stack is. Your stack is never. You'd have to have 100 parts in there to get to 1 millimeter high. So the
Right.
robot basically just assumes that it always has to go to that very bottom position every single time, like all the way down to the breadboard.
Okay.
Um, and then that way that keeps other things constant. In the way that the palletizer is typically set to be set up, wherever it picks the part from, it will retract. Like this exit point here. Um, where is it? It's called blow for some reason. That's odd. There must have been a misassignment in when I unsuppressed and resuppressed this get stock. This is supposed to be exit and approach. This exit point,
I'll change it right now.
is it below, set to below?
I am. I didn't have the program pulled up here. Something. All right. Program, and we're looking for which subprogram is it?
Get stock.
Get stuck. First one. Show the tree. I've got get stuck. Show me where in the program it is.
So it's going to be inside this loop, inside palette 2.
Side palette 2.
Add each item.
Add each
generate
item.
movements. And then it says first move L. What's that name on the first move L?
Approach 1.
Ah, then you're fine.
Approach,
I think what happened.
Yeah, generated movements. At each item, generated movements. Move L. Approach 1.
Perfect.
Then I've got the folder for approach. Wait. Then another move L. Tool action point 1. Another move L.
Perfect.
Exit.
Then you're
2.
good.
Okay.
You're good. So I think what just happened is sometimes what happens, it's weird. If you suppress an entire subprogram that includes a palletizer, then if there's another palletizer, or if you generate a palletizer after that while this is suppressed, it will take the next available name. It'll say tool action ploy _2. But if you suppressed something that's tool _2, tool action ploy _2, then it'll take that variable name and be like, oh, this is mine now. And so then you'll have two waypoints that are named that. And then when you unsuppress this, it'll be like, oh, wait, hold on, you can't be named that. And it'll rename something else. It'll do _3 or whatever. So I think what happened is I suppressed this and I may have accidentally renamed.
That sounds like a fun thing to figure out.
Yeah, the first time it happened was pretty rough. But yeah, I think what happened is I suppressed this folder and then must have renamed the approach point as a blow off sequence because I have blow 1, blow 2, blow 3, blow 4 for blowing off the vice jaws. But the concept is still the same. So what the robot is doing is it's going down until it runs into something or until it reaches a tool action point. And then there's a little bit more detail here, but basically also tracks if that position is truly empty. It says, okay, now that I've stopped at this waypoint, where is my position with respect to my actual target point? And my target point is tool action ploy _1. That's what this reference point is referring to. It's saying, where am I now with respect to this reference point? And if that distance is low enough, it says, okay, we clearly didn't run into anything. On the contrary, if it runs into something, then it'll say, okay, how far away from my target point am I? Once it's done the double tap to make sure that it's filtered out false contacts, then it says, okay, how far away from the bottom of the stack am I? And if that's if empty disk greater than empty threshold, then it'll set that cell. It'll say, okay, we've got parts in the end feed, and then it'll go and grab the part. And then if it's happens to be in the very first position or the very last position in the palletizer, it'll say, okay, I'm going to set last empty to true. If there's nothing in the last position, it'll say last empty equals true. If there's nothing in the first position, it'll say first empty equals true. And if both of those are simultaneously empty, so if it goes to the last position, that's empty.
Gotcha.
Then goes to the first position, then it's empty.
How you calculated that?
Yep. Then it says, okay, there must be nothing.
Okay.
Yeah. It says there must be nothing. Go home. No more parts.
Okay.
So yeah, if empty.
So you don't have a counter set up then.
No, don't need a counter. You just blind. You can blindly just feed parts into it all day, and it'll just keep rolling.
That's nice because I'm so used to having a variable for the counting parts.
Yeah. Yep.
And then you go to load a half a pallet, like like one of our pallets holds 216 pieces.
Yeah.
Every time we run that job, you end up, we can only load 100. There's only 100 left, and if someone doesn't know, they just let it grab 116 empty positions. Until it gets to one. Or if like the machine stops and you have to restart it, you either go back and like reset you want to add 5 pieces, you have to go like manually change the variable or let it start from the beginning. So that's nice.
Yeah, so this has been a game changer once we figured out how to get it to just blindly roll through. I use this for every install that I've done in the past 2 years has been this way. You may run into a bit of a pitfall with this reference point here. this is hard coded. Like this is a script call, or
Okay.
not a script call. It's an expression. So this is not a variable that you can find in a drop down list. It is manually typed in. That if you ever manually type in a variable, it will, as long as you type it correctly with the correct capitalization and spelling, it will refer to that actual variable name. The
Right.
only thing is that if you change, if you reteach your palletizer, or if you delete it and set up a new one and copy this line of code over, this reference point will stay as reference point. It won't update to be reference point _1. So see this feature? This is what it's actually pulling from, is this feature.
Okay.
And so reference point _2 is a different reference point. And if you update your palletizer by reteaching using the wizard, the generated movements at each item. So if you redo this wizard, and then what I always do is copy all of this. Let's see.
Okay, I need to write that down somewhere, because we have some parts that are 8 inches long and some that are 3/4 of an inch bar stock.
Yeah.
So we're gonna have different locations for the vacuum cups coming down.
Well, the nice thing about the way that we have the infeed set up is you actually don't need to reteach when you change stock size, as long as you set it up correctly. Yes. So that's the whole thing with this little nifty thing that we've included right here in the initialize vars scripts. Payload calculator automatically sets the payload based on the size of the part, length, width, height. It'll automatically pull the payload and will update the payload center of mass based on what your current TCP payload is, and then it will basically add in that part and say, okay, this is your new payload.
Wait, so how does that work? You go.
It's a two body point mass, and let's see. The script that you call is set two body payload, and that's done anytime. It's already built in. Like you don't have to add it in yourself, as long as you use your grip part and ungrip part subs, which it's all built into the template as it stands. As long as you use those script calls to call your grip part, that's not the correct one.
But so if I change from a small part to a part that, say, like, I think this is like, let's call it 6x6 by ½ inch.
Yep.
How would I set that?
You'd go to part specs. I would basically, this is my template folder. I always just press it.
Look at that.
And then go copy paste, and then stock length, stock width. This is in inches. Stock height, and then select material. The D aluminum KGM3, that's an installation variable. So if you go D_brass PTFE steel, so those are your options for selecting. And then you just hit that, and it says, okay, that's your density, and then it knows what the volume is based off of that. And then anytime it grabs a part, like if you use as long as you use the grip part subprogram with a script call, then it will do the grip check. It'll say, okay, grab on the part, make sure that you grabbed onto something and not nothing. It'll do the logic check for all that. And then it says, okay, I've got a part in the gripper. That's true. Then it'll say set two body payload, and it'll run this script here that tells it where the new updated center of mass is. So you don't ever have to do that manual teach of the payload, all of that. You can it just runs this script, and that takes care of it for you.
When Skynet and the androids take over the world, I'm blaming you.
No, this is not, this isn't AI. This is just
regular. I know.
Yeah, the AI stuff is
pretty nuts. I got like my slide rule over here.
Yeah, totally.
Stock mass. All right.
What are those things called? The with the beads on the rack of beads. Yeah. Abacus. Yeah. So then, additionally, this infeed calculator. This, and I'm glad we got here, because this is actually the meat of what you may be needing to spend time to set up. But when you set it up, it's going to save you so much headache in the future. You're never gonna have to. You're never gonna have to, as long as your four corners of your in-feed system do not change location. You should always be able to just keep the same exact loadout, never touch this palletizer, and all you do is you update your part specs, and everything else will click into place, because this in-feed calculator just takes if you have a known size teach block, let's see, teach part, global teach part L, global teach part W, teach part H. So you manually set these when you are setting up your in-feed palletizer. You basically you have one of those parts centered in the gripper, in the vacuum cups, and then you guide it so that it's nice and snug and square to the bracket, and then you set your points.
At the top or the bottom?
It's going to be at the bottom. So basically, what you want to do is get the part all the way to the bottom, and so where the part is touching the in-feed breadboard, then touching the two sides of the bracket, nice and square. And then importantly, this is a non-intuitive step, and it makes it easier on the coding side, but more difficult for the user. And so I know that eventually I want to change this. If you then once you have that position, then you let go of turn off the vacuum, and you remove the part from the gripper, and then guide the robot down using move in-feed plane Z-, and just bump it down till the cups are just touching the breadboard.
Okay.
And then once they're touching, then that's your first corner point. It's easier if you can. So rather than having to do that 4 times, I only ever do it 1 time.
Make sure you set the right material size too when you do that, so the program knows. Okay.
Yep. Well, you can do it. You can do it after you've picked up your corner points, but you want to do it before you run your program. So if you update the script for in-feed calculator, if you change these to whatever size teach block you used, once you've entered in the correct one, then your in-feed palletizer will work correctly.
Oh, so you do set a teach block size.
Yeah. It can be the same size block as a part that you're actually running, but I would recommend that you just take one of those raw stocks and then literally write with Sharpie on it, write teach block.
Just keep it in the kit.
Yeah, and I literally just put it inside the robot control box.
Okay.
But yeah, so once you have that set, then you set up your 4 corner points. It's worth noting, and if you don't remember this, or didn't write it down clearly enough for you to remember exactly everything, you absolutely can call me up and I can just walk you through it. Because I do know that it's over time it becomes a real time saver for me.
I want to set it up right. That's why I haven't.
Yeah.
I could have brute forced this thing and had it running a while ago, but I didn't really want to
mess
up. This is what you guys do.
Yeah, totally. And so, the thing that I like to do is, where am I here? Above and feed. The thing that I like to do with it is, given that I know the spacing of those holes in the breadboard, you can actually count, like once you have your bracket location set up, you can count how many holes are.
Just do a move.
Yeah, you just do a move. You basically just, because I don't know if you ever use the edit
I do that
position.
A lot. Yeah, just hit plus or minus. And,
I just plus. It's like typically for us, our system setup, it's like plus 700 in X, and then you just move here, and you can manually. So that way you don't have to actually like fine tune it. Like you just only do that thing with the part in the gripper just the once with that first bottom left bracket. And then you go bottom right, top left. You just go around the room and basically just add your XY offsets using your in-feed plane.
Okay.
And so, like in this case, it would be given that you're going to have to get out of the way of the bracket. So if I go, okay, if I want to set up, I've taught my corner item 5, boom, we're good. Then I want to go to corner item 6. I'll go move tab, and it's like, okay, I know that it's right along this axis, plus 650. I'll go plus 650, hit OK. Oh, it's not going to like that. That's weird. It's flipping around. We'll go minus 50. And it doesn't like that either. Plus 400. There we go. So let's say it's 400 millimeters away. This is part of the reach study. You know, if it wigs out like that, it's because the reach study was you were too far away. But if so, you're saying, okay, you want to go to this position. I have to go manually. I have to manually bring it up, and then bring it over. And then once you've cleared all of your brackets vertically, it's like, okay, now it can dump straight down. Then you hit OK, move to position, and it'll go to its spot. But yeah, if you go using these offsets, and then you go plus Y 550, however many holes it is, then you can just march through and do that.
Okay.
Um,
do you normally see any issues with? So you can see the board like these, trying to get a good angle on it, but like that looks like it's awfully close to the robot. Can you grab that?
hold on. I can't see what you're showing me.
Can you see my screen?
Hold on, let me see. Stop sharing. I can't see your screen. Can you share it with me?
Oh, this whole time I thought I was
Oh.
sharing it. Why it says it's sharing?
Really?
You don't see my camera?
No.
You can't see my amazing red headset? Oh, come on.
No. Yeah, what's up with that?
It says the camera's running. The camera's green. I see my picture at the bottom.
Yeah, no, I'm not seeing. I wonder if it's because I'm recording.
Could be.
In any case, if you just send me a picture via text message, I can give you an answer. Like, if you wanted to send it right now, I can definitely give you an answer.
Yeah, well, this ties into my my other question is regripping. Do you guys normally regrip?
It depends on there's a couple answers to that. Sometimes yes, sometimes no, and it depends on how precise we need to be with picking up the parts. If you're fine with the part being within like a half millimeter, so like 20, 30 thou laterally and in basically in machine X and Y, is if you have enough forgiveness in your vise such that the robot doesn't need to pick with dead nuts precision in order to fit it into a narrow gap in your vise.
Okay.
You don't need to do a regrip. A regrip is great because the repeatability is
I
so
regrip everything now just because especially on pallets. I mean, your pallet's super rigid. This machine is new. I'm dealing with a 10-year-old you are on my other setup.
Yeah, totally.
That's got some like little tolerance issues and quirks. Yeah. But the regrip has changed everything for me. Especially loading like a collet on a lathe or whatever. But if I don't need to do it, I'd rather not. It slows it down.
Yeah, totally, and that's why we don't do it unless we have to. There's been it's rare that we have to because most of the time the way that our palletizers are set up are precise enough that and we also have enough forgiveness, especially given the robo wrenches now, you can open it up as far as you want. And as long as your soft jaws have a wide enough landing for that, then it doesn't
soft jaws
matter what's
do.
going on.
It's more about the Mighty Bite jaws.
Yeah, exactly.
They have like a 1/8 inch land, so
yeah, exactly.
That doesn't give you a ton of a ton of wiggle room.
No, yeah. So, yeah, given that, we've actually on some of our applications we've actually added in some extra landing space
Okay.
by modifying the inside of those Mighty Bite jaws, so you can bolt something in there, so that we have a wider landing, which
Okay,
has
I'm
helped
glad you
us.
said that. I thought about doing that too, just making like a little aluminum
Yeah. Yep.
surface so that you got
Yep.
more play. Okay,
Yep. And
that makes
so
sense.
yeah, so we have done regrip, and for the exact same reason that you do it, it just makes things easier and simpler. But our default template thus far has been enabled us to not have to take that extra step of regrip, um, unless we need like the precision so much where it's like, hey, we can't afford to have any piece of stock, even slightly out of position. Like say an operator is kind of sloppily putting stock in. We don't want to rely on the operator to get that stock to be, square and snug on the bracket. Let's just do a regrip and avoid that headache completely.
Okay.
If you need the precision for when you're loading it in the machine for like whatever your fixturing is, like if you have a really it's called a quick change call it that has only a tiny bit of wiggle room, it's like you might have something where it's like, okay, you need to be able to regrip the round bar stock, so that it's you reliable positioning. There's no
Yeah,
because
well,
we don't have the wiggle room.
yeah, it's different
So
when it's like round parts coming off. It's different.
yeah,
Um,
so yeah, given that we have done regrip,
okay.
don't need it. If you set it up the way that we have it, you shouldn't need it. But there's a possibility for down the road where it might come up again. So um, let's see, we went through, you teach your corner item 1 with the block in there, then make sure you remove the block, drop it down to the bottom, and then teach
Okay.
it. And then basically just do XY offsets for the remaining 3. And then you're going to go through and do your wizard. Uh, Redo wizard. When you redo your wizard, it'll clear out everything here. So all of this is going to go away. So you have to be mindful of it and get ahead of the curve. I specifically have these folders in here so that you can copy paste them out of this tree. So what I do is I grab this tool action, I'll cut it, paste, tool action point, cut it, and paste. I'll just put it somewhere down below so I can access it later. And then approach, cut it, and paste. And mind you, these folders, I've named them the same thing as what they're closest to be. So like this approach, this waypoint should be named approach. I don't know why it got renamed, but it was probably because of the scratch, whatever.
Okay.
So if this is my approach, then it's like, okay, I know that this folder, once I've redone the wizard, then it's like, okay, I know this folder goes right below that. And then the tool action point. I would actually take a picture if I were you, and just for the first couple times that you do it, take a picture of the state of the. I'm just
Yeah,
undoing here.
been screenshotting everything here.
Yeah.
So
So you
you're saying
screenshot.
that you save those corners before you do the wizard, or while you're doing the wizard?
No, you do. You have to do it before, because basically the wizard, after you guide through, the wizard will use these corner items
Okay.
as the references, and then it'll build up the rest of this code, or not the rest of it, but it'll build out
Okay.
the
I think
structure.
that's a little different than what I'm used to. That's a little different than the old
Yeah.
CB style. Okay.
Yeah. So it's worthwhile to take a picture to make sure that you're not missing anything. And I expand out everything just to make sure that you're not missing anything. You just take a picture of all this stuff. Make sure you got these lollipops all the way out. Take a picture. Scroll up, take another picture. Scroll up, take another picture with everything expanded out fully.
How'd you get that screen to show bigger? Is that bar on the?
It's this little arrow deal.
The
little
hamburger.
Here.
Where is it?
It's this little arrow here. It's like a vertical bar with an arrow. You click that.
I was looking for a way to do that all day
Saturday. It's nice.
Yeah, I have. It's just a different. It's a big button on the bottom on what I'm used to.
Oh yeah, totally. So yeah, that's that right there.
Is there a way to zoom in, like make the screen a different size, or is it just one size? Okay.
No, it's just one size, unfortunately.
So a stylus or a mouse is helpful.
Yes, if you have
Okay.
big fingers, if you got hams for hands, or
Yeah,
some
like
of
I
our
can't, I
customers.
can't even, I can't type on an iPhone. I gotta. Yeah.
Yeah, yeah. So stylus is definitely, it works on the touchpad and it's nice. Um, yeah, so making sure you include every single one of these line items, so that you can insert them back in the right spot, and just know that you can save a lot of time by
Okay.
um, these inner tool actions. So this one you can't actually. I think you might be able to copy it, but there's something weird about it. Like if you try to delete this